Video I skipped one thing. So just interesting thing I would like to tell you that this load current, when we draw up to 1 ampere, I was getting the constant output voltage 100 volt for example, but when I am drawing 1.1 ampere it get dropped. When I draw 1.2 ampere it get dropped further. When I will draw 1.3 ampere it will drop further, 1.4 ampere it will drop further. So that means the maximum current rating of this power supply was 1 ampere. So if I draw the current from more than its rated value, the output voltage will get dropped, and this is the case when we say that power supply is loaded. Now let's come to the next two factors. One is the ripple in DC power supply. We all know that ripple is nothing but it is the unwanted AC component at the output of DC power supply. A common sense. The thing which is unwanted, that means it should be very, very low. In general purpose linear power supply is usually available in different labs. They have typical value of ripple less than 1 millivolt RMS. This RMS stands for the AC voltage. But some very good power supplies, they have a typical value of ripple less than or equal to 300 microvolt RMS. So unwanted thing is now in microvolts, which is definitely better than what we had in 1 millivolt RMS. So lower the ripple, better is the power supply. Let's now come to the next is the display resolution. These days we usually have either a TFT display or LCD display or 7-segment display displaying the voltage set at the output of power supply. Say for example this decimal point, then again I am having these 2 digits. For example, I set the output voltage 10.01 volts, means I am setting after decimal 0.01 volt. That means it is 1 divided by 100. I multiply by 10, divide by 10, so it becomes 10 into 10 raised to the power minus 3, and that is equals to the 10 millivolt. So I can say that the power supply with this kind of display is having 10 millivolt as a display resolution. If I add one more digit after decimal, so now in this case I can set the output voltage 10.001 volt. That means 0.001 volt, it is equals to 1 divided by 1000 volts. That means it is 1 into 10 raised to the power minus 3, so that is equals to the 1 millivolt. So now this power supply is having a display resolution of 1 millivolt. In this, the display resolution was 10 millivolts. I can set the 2 voltage ratings from previous to the next by 10 millivolt, but here I can set the 1 millivolt. So this is definitely much better than what this 10 millivolt. But mostly people have 10 millivolt as a voltage resolution, display resolution. The next video will see 2 important parameters of power supply, that is constant voltage mode, commonly called as CV mode, and secondly constant current mode called as CC mode. Thank you.